Welcome back. In this session, we are going to understand why Kubernetes become essential. So far, we have looked into history of containers and how containers gain adaptation and how industry moves towards tool like ECS and Kubernetes to manage container at a scale. But orchestration was not just about managing the containers. So it was also about managing the new way of building application, the microservice architecture. Now we are going to understand what changed in the software architecture and why that need made essential for orchestration tool like Kubernetes as absolutely important. So to understand that, let's start with what is monolith application. So when we say monolith application means has large code base deployed on single machine. So let's start with example of a e-commerce platform. So we know in e-commerce platforms we have a different modules that's designed for different purpose. So I have took very simple example. So here we see we have the inventory that manage the all product list. Then you have the shopping cart. So people go ahead and add product to the shopping cart, and then finally they do the payment. So this is very simple architecture. Here we see only three component. But in the real time, in the real world e-commerce application, and if you take example of Amazon, then they have more than 50 component to run amazon.com. Now imagine what happened in monolith architecture. All these three components running on single virtual machine or physical server. Well, this is looks fine as long this is three or maybe five, but imagine Amazon.com when they have 50 components and all these components are running on single physical machine or single virtual machine. It's create a lot of problem, right? Now let's look into some of the problem of this monolith application when we are running from the single instance. First is scalability limitations. So in monolith architecture, what you see on the screen, so entire application must be scaled together even if only one part of this application, let's say the inventory, need to be scaled or need more resources. Now let's understand that. So let's say there is 100,000 people accessing this application, then maybe this 100,000 people will go and browse all the product. But here only maybe 1% of it will come to the shopping cart and even less will go to the payment. Now on the, let's say, the festive time, if we need to scale this application to have 1 million request, it means we are going to scale this entire application where we know only 1% of the whole traffic coming to the payment section. So this is scalability limitations. Next problem is slow development and deployment. So as you see, we have the three component for the simplicity, means there is different teams working on this individual component, right? So all teams work on the same code base because they are part of the monolith application, and that lead to the bottleneck, merge conflict, and wrong and long release cycle. So here if different team is working, so it means we are completely depend on the release to make sure all application code is stable, right? So we have to check with the other teams as well. Hey, are you in stable, your code is stable? If yes, then we will go then deploy the application. So when we are depending on the different teams, so our release cycle will be long. Again, another problem is the tight coupling. It means if there is, let's say, a small changes we need in the payment module and we need to deploy it immediately, it means we have to test the entire system, right? So this testing of whole component, all application, and again retesting, redeploying need to be done. So this is called tight coupling. Another is technology locking, means all this component of this application need to develop in same technology. Like there are many more challenges like reliability risk, hard to understand and maintain the application code, deployment challenges, and so on and so on. So because of all these challenges, people started thinking to go in more robust architecture, and that's where microservice architecture evolved. Now how this works, let's quickly understand. Again, we are going to refer the previous architecture for the simplicity. So here what we see, we have three component: payment, shopping cart, and inventory. Now if same application we need to make a microservice architecture, what we will do, we will create a component called UI microservice where every user come and they will try to access the application, and from here we will run a different component that will be accessed from the UI microservice. So we will have the different component. If someone need to do the payment, so it will call the payment module. If someone need to add any product to the shopping cart, then this will call to the shopping cart module. And if someone need to browse the product, their details, images, they will call the inventory module. So here all request, sorry, we see all requests coming to the UI microservice, and from here based on what user is doing, request is going to the different microservice, and now this microservice can run on its own virtual machine. Now again, let's take example of Amazon. As we said, Amazon has more than 50 component. Now what does it mean? We will have at least 50 microservices when we are running amazon.com. So do you think running this 50 microservice on virtual machine is good idea? Not at all. So this could be run better on the container, right? So that's where needs of the container come into the picture. Now let's look into the challenges of running this microservice with the container. Here we said Amazon has 50, let's say 50 component. And in one of the reinvent video I have listened, one of the product owner said they are running 100,000 microservices for amazon.com. Yes, 100,000 microservices for amazon.com. Now imagine if we are running all these microservices on the container, how do you manage this? Now this is the one of the other problem of running container in production from the architecture perspective. So we need a tool, orchestration tool, that manage all this microservice complexity that exploded from couple of containers to hundreds of containers. For what? Because it need to be deployed, it need to be scaled, it need to be monitored, it need to be connected using the service discovery, and it should be self-healing. If something is failing, it should be able to come itself, and all those things we can done with the orchestration tool, and one of them is the Kubernetes. So here I was trying to explain you why we need the orchestration tool. So just I was trying to make sure you literally understood needs of the Kubernetes, a orchestration platform. So if you are going for the interview, you will be able to explain your interviewer both perspective, technical perspective and also software architecture perspective. So that's pretty much for this session. In next session, we are going to understand Kubernetes in more detail. What is Kubernetes? Thank you so much. See you in the next session.